Okay. Nice comfy chairs here. Well, hello everyone, welcome back. Now we're going to go into the next SSA policy forum, and this is a topic that I'm really excited to talk about with y'all because it's something that when Zach and a couple other colleagues and I first started talking about it felt very taboo, but it is right-of-way, in particular in relation to large constellations in low Earth orbit. When you've got two satellites that are going to potentially collide, who moves? How do we decide? Do we just call each other and very casually say, like, oh, you move to the left, I'll move to the right? Or is it more complicated and nuanced than that? And so today we've brought together a panel of experts, both here with us and also in hybrid form, a couple of folks who are joining us virtually. So let me introduce them right away. I know most of you will probably already be familiar with these folks. We've got Daniel Trogi over at the end. He's a Director of Integrated Operations and Research at Comspoc. Ms. Ruth Stillwell, she's the Executive Director of Aerospace Policy Solutions. Mr. Zach Donahue here, he is a scholar in residence at the Leeds School of Business at CU Boulder. And then all the way from Switzerland, we have Dr. Emmanuelle David. She is the Executive Manager at the EPFL Space Center. And someone else who many of you probably already know, Mr. David Goldie, still hard for me to say that, Goldstein, Principal Guidance, Navigation, and Control Engineer at SpaceX. David, I'm sorry, I'm not going to be able to call you Goldie until I properly meet you in person, but I'm sure many of the other folks here already do. And so with that, I would like to hand things over to Dan. And Dan, you have a presentation for us, and what I would like to hear from you in this presentation is, what are we seeing in low Earth orbit in terms of growth? What can we expect of active-on-active maneuvers in the future, and is our rate of growth sustainable?
Yeah, thanks for that question. Indeed, we are seeing a dramatic growth in resident space object catalog on multiple fronts. And by the way, I see my role in this panel to try and kind of set the stage and the backdrop for rules of the road. We are involved in developing and kind of drafting up some rules of the road, but in this presentation, I just want to focus on kind of the backdrop here. So first, the number of active spacecraft is increasing due to the deployment, obviously, of large constellations. Today's 5,000 publicly acknowledged active spacecraft reflect this growth, which has doubled the 2,000 active spacecraft from 2017 and includes today 2,200 large constellation spacecraft. So this is a notional depiction. It has the applied for satellites through the FCC and ITU, and there are 66,000 applied for satellites. And you might say, well, this is very alarmist, you know. There really aren't going to be that many because companies will fold before they ever achieve orbit. But 2/3 of these are from SpaceX at just under 42,000 spacecraft. And no, this does not reflect the new privateer space constellation that was announced a couple days ago here. But perhaps the more interesting and challenging question for us is just how many of these proposed large constellation spacecraft are actually going to be realized. So naturally, that's a function of who the operator is, their resolve, their resources and skills, and their ability to get a license. So far, we're actually sitting, let's see, hit the right button. We're sitting at about 65%. Again, SpaceX, robust, and resolve. So the second piece of this is, what is the debris environment doing? We saw some good numbers from Colonel Broder just now. We can see in 2005 on this spatial density depiction of public RSOs that there was a little bit of crowding near the poles for sun-synchronous orbits, but basically not much. And then over the time, with the debris fragmentation events, ESA estimates there's about a dozen happening each year. You can see the ASAT event and the Iridium Cosmos event. Things have gotten a lot busier up there. And now even on the bottom right, you can faintly see the large constellations showing up in this depiction. While this is not yet dire, it does warrant our careful attention. The combined growth in debris and active satellites naturally leads to a substantial increase in collision risk and avoidance maneuvers. And that takes a lot of computations to figure out, but that's been part of our research here. we were asked in last year, I guess, to do an assessment, CSSI and the Space Data Association, looking at our historical conjunction assessment products to find out how many conjunctions we saw in that time. The nice thing about the Socrates tool that we run is it goes back to 2005. And then Space Data Association, while it goes back to 2010, we did use the data on our latest cloud instantiation, which went back to only 2017. But you can see the number of conjunctions, these are normalized to a distance, that have happened over these 16 years now. And what's interesting is that other than the Chinese ASAT and Iridium Cosmos, it's been kind of largely flat for a long time. But just in the last 3-4 years, we've more than doubled the number of conjunctions. So it's not just about the catalog size. It's about what's the implication of that in terms of conjunction rate. Now, if you want to understand this growth and the collision risk a little better, I recommend to you the NEAT tool, Number of Encounters Assessment tool. It's freely available on ComSpot's website. We announced it a couple years ago. But it estimates how frequently an operator would receive conjunction warnings, decide to maneuver, and if they don't effectively maneuver, have a collision. So you can note the 3 spikes there in that depiction. This is a depiction of altitude and inclination, and its collision rate, and so forth. And so you can see the SpaceX constellation, you can see the Iridium Cosmos altitude, and you can see the Fengyun altitude spikes there. Now, regarding our preparedness for large constellations, substantial progress is being made, particularly in the commercial and academic communities. Space Data Association is now in its 11th year of providing space flight safety services. Space Safety Coalition, which I administer, continues to codify best practices for safety and sustainability, and we have nearly 50 endorsing commercial companies and entities. The SSC is also collaborating with the Secure World Foundation and CU Boulder, and we'll be hearing from Zach shortly about rules of the road. Operators like SpaceX are seeking automated approaches to avoiding collisions. We have a brand new proposed space traffic coordination standard that I'm working, and we're also working actively on a large constellation standard within ISO. We are developing and finishing development of a new orbit data message and also a updated conjunction data message to better serve both the SSA, SDA, and operations communities. There are new launch collision avoidance tools made to maximize launch window availability in all domains, air, near space, and space. We recently finished development of STM-related terminology through the IAF, and then commercial SSA centers and service providers continue to innovate and provide high availability, mature services. Yet much remains before we can achieve a truly effective SSA and STM system. As shown in the previous chart, there's really no consensus, which we presented yesterday here in this forum, on what constitutes something that should be avoided in terms of a close approach. And this is because operators are choosing that to fit their mission goals, their customer set, their SLA, et cetera. SSA and operator products are typically not sufficiently accurate to support the way in which operators are using them, and that's another serious piece. Lastly, AI and automation are obvious paths for us to pursue because, as was mentioned earlier, we have now, with large constellations, millions of conjunctions, close approaches that we need to check and screen and do something about. But if you don't have really exquisite data to feed those AI algorithms, that's where we can fall short. And right now, I would say we have some work to do there. So, you know, just as a soccer player, when they pass the ball to somebody else, needs to pass the ball to where the other player is headed, not where they are. I do want to say I think it's time we address these gaps, we need to look at not just right now, which is already tremendously different than 4 years ago, but we also need to know, where we're headed by 2029, for example. We need an effective SSA and STM system by that time. So thank you very much. I look forward to your questions, and I look forward to comments from the colleagues here.
Thank you, Dan. I always find that my nerves go up just a little bit once Dan has started bringing out the charts, and I think, oh God, it's all going to come crashing down. Let me jump over to Ruth real quick. We often see that the regulations and the rules often trail the technology. So we start doing great things, but our regulatory system isn't always there. Can you tell us a little bit about what does the regulatory landscape look like at the moment for LEO in particular? Is there any type of international coordination for some of the new constellations that will be coming up? And are we even at that point that we should be having this discussion?
So I think it's important to have the discussion, and there have been a lot of presentations about the difficulties in a regulatory framework in a non-sovereign area. And so what are the other ways to solve that problem? So I would say I'm going to answer your question, what is the regulatory framework specifically for right-of-way, and not all of the other body of space law, but specifically for right-of-way, the regulatory framework is please don't crash your satellite, and really please don't crash it into somebody else. And that's an important premise, though, because where do we go from there? And the realistic outcome is not that we are going to have an uber authority over space who is going to tell you where you can go and when you must move, but a network that allows us to self-organize. And we can look to other domains. We talk about maritime, we talk about aviation, and we talk about right-of-way. And I want to make one important point here. Right-of-way is not the correct term, because we do not imbue a right to do what you want to do because you have priority based on a series of agreements. If you look at maritime in particular, the term is give way. It is not who has the right of way, but who will give way. Having said that, it's very convenient to use the term right of way, and now I'll go ahead and use it. So, sorry about the lecture and the mixed message. But when we talk about who gives way, there's a couple of ways to look at it, and the first is situational. In a situational, we're talking about the physics. What is the most expedient way to resolve a conflict? But in the larger body of standards, norms, and regulations, we look at priority. And priority is a decision-based, a policy-based decision to say that I will give greater deference to this vessel versus that one. And a lot of the things we look at in priority can be government over commercial, commercial over government. Also, if there are human beings on board, and is there a risk of loss of life, and does that deserve a higher priority? But those are agreements, and that requires a lot of dialogue and discussion. So let me get back to the standard, which is please don't crash your satellite into someone. We need more information in order to do that, in order to self-organize. And when we look at regulation versus norms and standards, I'm going to use a very simplistic example, and that is walking. When we talk about rules of the road, there are very clearly defined rules and standards, and that in the United States, if you drive on the right side of the road. And the reason you drive on the right side of the road is because opposing traffic will drive on the right side of the road, and we can effectively miss each other. But when you are walking, because you live in the United States of America, you will naturally self-organize to move right when you encounter somebody head-on, because we are conditioned to do that as a matter of safety. But if you are in the United Kingdom, you are conditioned to move left because of their rules of the road apply when you are self-organizing. When you are in London Heathrow Airport, it is not enough to know that you are in the UK. You need to know where the other person is from to anticipate what they are going to do. We need more information about each other. And that is true in the space domain. We can have concepts of right-of-way, principles for safety, but they are dependent on having enough information about each other. That information includes a reasonable expectation of what the other actors will do, as well as a knowledge about the health and the ability and the capability. Is the satellite you are encountering able to maneuver? If they're not able to maneuver, the decision's quite easy. If they have some limited capability, then you can start to weigh, do we coordinate and each move a little bit? But then you have to look at the motivation. Is there a willingness to move? And that's where we start to see the develop of agreements. And we see a proliferation of bilateral agreements. And I will say, as I've said in many of the sessions, bilateral agreements are necessary and problematic. And what we're seeing in these agreements are this priority question to say, I will give you priority. We see this in the NASA SpaceX agreement, that SpaceX says the NASA assets have priority. But that doesn't create a standard throughout the community. So we need more visibility into willingness and desire to reach that standard so that we can self-organize in the way that we do walking. And the last thing I want to bring up, and this is a very important point in every domain, a vessel in distress has priority over everyone else. We need to know if you have a satellite in distress. The other actors in the domain that may be affected need to know whether you are in distress. And that should not be considered a commercial issue, a national issue. That should be considered a safety issue for operation in the domain. We have a Mayday practice because it is a means to alert everyone else, regardless of who they are, what country they are, friend or foe. We have a Mayday practice so that we have that awareness. So we don't yet have that in the space community. So as we move forward, I think the step, to answer your question, the first step is how do we get enough information so that we can self-organize, recognizing there is not going to be some authoritarian control over the space domain. And once we have that information, how can we use it to look at what priorities are appropriate for the nature of the domain we all want to preserve?
Thank you, Ruth. That's excellent. And once again, as my girlfriend continually reminds me, it's all about communication. And in that sense, folks, if you have any questions, please make sure that you make it onto the platform. Ask lots of questions. You know, we've got some of the best experts here, and they'll be able to provide us with a lot of insight. Speaking of which, let me now turn over to one of our hybrid guests, David. As a representative of SpaceX and of course Starlink, I think everyone is looking to you and really watching how Starlink is developing precisely because of the reasons that we're talking about today. Can you tell us a little bit more about what measures SpaceX is taking to avoid collisions? Tell us a little bit about the automation system that we've heard so much about, and also how is SpaceX working with other operators and partners to make sure that that the operations will be free of collisions?
So. One of the things that I learned when I was in the Air Force is that when you're being interviewed and you're asked a question, you can always say, I'm not going to talk about that, but what I will say is, and so I'm gonna do that a little bit here to you. I'm disappointed that I couldn't be there in person, but with the Inspiration 4 mission, decided to stay back here and support the collision avoidance efforts for that, which is going really well. Working directly with the great professionals at the 18th Space Control Squadron. I guess in the big picture, this right-of-way issue or give-way issue is super important, especially with more systems coming online that where the decisions are made on board the spacecraft, and like Starlink does. And so, as we sort of work through that, some of the things that I think need to be considered are, the timeline of when a decision is going to be made, because, in the case of SpaceX, for our satellites that are in their operational orbit, we make the decision. The satellite makes the decision on board at about TCA minus 12 hours to maneuver, and if we're orbit raising, that timeline goes down to about 3 hours. So the decision is important for when a maneuver needs to be communicated and done by the spacecraft. In the quite public conjunction between OneWeb and SpaceX back in March, OneWeb's timeline is around 24 hours, and so SpaceX deferred to OneWeb to maneuver because their timeline was longer and they wanted to ensure the maneuver was going to occur. And so we temporarily disabled our CA system in order for OneWeb to make that maneuver. And so we sort of gave the right of way in that case. So that's consideration. Obviously the criteria by which you're going to decide to maneuver, in the case of Starlink, we maneuver with if a PC is greater than 1 × the -5th. That's a lower number than for many other owner operators, and so if another owner operator has a different criteria, then perhaps whoever has the tighter criteria should be should take the right of way to maneuver. If a satellite is orbit raising is also quite an important one. If you're in your operational shell and a satellite is coming through that's orbit raising, especially if they're using low thrust, then perhaps the priority should be for them to avoid any satellites in an operational orbit, and also sort of how a satellite maneuvers is also important. If they're going to use differential drag versus having active propulsion, then that could be a consideration. One of the difficulties in this whole area, though, is we don't want to incentivize satellite owner operators to not include maneuverability because they believe that others are going to avoid them. And so yeah, like everyone should be building satellites that can maneuver in order to keep space safe, so that this decision for right away, like we definitely need to be working it out. One other piece is our owner operators screening their ephemeris and covariance and making that publicly available, because that's a very important point, because whoever knows their position better, likely the other owner operators should maneuver to avoid a satellite that they know their position better. So that's definitely another consideration, and that's another area where we encourage all owner operators to publicize their ephemeris and covariance, and also to have it screened by the A team. But regardless of sort of this right-of-way issue, collision avoidance is a team sport for sure. And sort of to answer the original question, SpaceX has been working really hard. In 2019, we were on a panel here in Maui, and it was after the AOLIS conjunction that was very public, and so we went to work on coordinating, and since then have signed the Space Act agreement that Ruth mentioned with NASA. We have CRADA with the Space Force. We have a good working relationship with ESA and the EU SST. We've stepped through all the details of our collision avoidance system with them. We have a great working relationship with OneWeb after that conjunction in March, and just fantastic coordination at the operational level. In fact, for the Inspiration4 mission, they jumped through a lot of hoops to be able to provide propagated ephemeris, like sort of at the last minute, just to make sure that we were screening it appropriately to protect Inspiration4. And so my hat's off to John Gainey and their team there for the great work that they did. Astroscale is another one. We've even had discussions with ULA to try to help address some launch COLA sorts of issues. And then sort of a big one for us is our great working relationship with Leo Labs. We recently signed a contract with Leo Labs for their collision avoidance service, and so they're doing great work, and super proud of the accomplishments that they have and the help that they're providing to us and to others. But in the absence of any sort of guidelines or coordination, SpaceX is going to take the responsibility to maneuver, and we do that quite often. And moving forward, it would be super helpful to have some like rules that we could all go by, whereby even if with two systems both wanting to maneuver, sort of as Ruth was saying, that we have sort of a rule set where any maneuver by both is going to reduce PC rather than sort of increasing PC, and we look forward to more discussions in that area, and seeing collaboration tools in this area like Slingshot's beacon tool, that whereby companies can come together to collaborate on conjunctions in order to have a place to share data that maybe is a little bit more convenient and adaptable than Space Track. So with that, I hope I answered your question. Kind of said a lot there, and look forward to questions.
Thanks a lot, David. It's much appreciated. Let me jump over also to Emmanuel, who is joining us from the hopefully sunny shores of Lac Léman. Emmanuel, please give us the international perspective. What do you see as being the implications of large constellations currently for industry at large? And will the operations of other operators be impacted well, negatively or in any way? How do you see this discussion about right-of-way and giving way from the perspective of other operators who might be impacted?
Hello, Daniel and everyone. Thank you very much for the questions. I'm very glad to be here virtually today, and I apologize for not being able to attend in person. So first, you asked me what are the implications for the commercial sector at large. Let's say that the economic growth of the space sector goes also hand in hand with the need to keep the space environment sustainable and safe, allowing also a fair and equitable use of outer space. This is the question that is raised in a lot of discussion and debates. So how operators continue to pursue their mission object while complying to sustainability measures to ensure sustained and sustainable use of the space environment. Let's say that companies are not just investing in sustainability, but they are also actualizing their commitment of responsible design and operation. And David just mentioned, I would say, a lot of examples how SpaceX designed its mission towards this goal. And therefore, I would say that the commercial sector is working hard to ensure a sustainable space, and this is also in their best interest. Then you ask me if large constellation, LEO constellation have an impact on the ability of others to operate safely. Let's say that those large constellations, they do have an impact on how others operate. Indeed, for example, last week, Professor Hugh Lewis from the University of Southampton tweeted that in the last Socrates report of the first week of September, there were almost 4,700 conjunctions of less than 1 kilometer, of which almost 3,000 involved at least one Starlink satellite. We know that the Starlink satellite, they have the capacity to perform collision avoidance maneuver, and they do it on a regular basis, according to some source. David, you can correct me if I'm wrong. There has been almost more than 2,000 collision avoidance maneuver in the first semester of 2021. And we see that this trend is going to raise as there's going to be more and more Starlink satellite, but also from other constellations. So inevitably, there is an impact for other operators to operate safely. There is an impact if there is, as we mentioned, no coordination, no data sharing, if the satellites are not equipped with collision avoidance maneuver systems, and also if the whole infrastructure around is not ready for, such as for space situational awareness and space domain awareness. And of course, if on top of that there is no governance which is agreed at the international level. Finally, I want to comment also if there is a need of conversation of right of way. And I would say, yes, there is a need of this conversation, and actually it's already happening in a lot of different forums, in open doors and also behind those closed doors. The initiatives are various, and Dan Altrog listed a few of them during his talk. For me, the biggest challenge in the conversation in the right-of-way is to ensure the fair access to space to all actors. Not that the companies with the strongest experience or with the administrative, which has the biggest means, have a kind of a priority on some orbit, but that space can be accessible for everyone. In order to start also the conversation at EPFL, we've been selected this year in 2021 to operate the Space Sustainability Rating along with the MIT, UT Texas, the European Space Agency, Bryce Tech, on the initiative led by the World Economic Forum. This rating is not aimed to be, I would say, a pass, go, no go for people to fly or not. The aim is really to promote sustainable behavior of space actors by issuing a recognized rating developed by experts. Based on the interest that the rating is raising, since I joined the project a few months ago, I can tell that there is the need for this. So the rating is based on 6 modules, 2 of which are computational, meaning that they depend on the parameter of your missions, the architecture of the spacecraft, in order to define the mission index, but also the detectability, identification, and tracking of the objects. The other modules are about how compliant the mission is to current guidelines, such as the IADC guidelines, ISO standards, but also national laws, the capacity of the mission to perform collision avoidance maneuver, and the level of data sharing that is performed. The beta testing is currently ongoing to test the rating and gather feedbacks from operators. And if you want to learn more about this rating, I invite you to talk to Maury Baja and Daniel Wood, who are present also on site here with you guys in Maui, and that are sharing tomorrow the SSA session. Regarding the right-of-way, the main connection we can do between SSR and the right-of-way comes in the way how SSR gives credits to the operators for several actions. And they will take to support coordination in context of conjunction warnings. First, the mission index module, which estimates the space traffic footprint, celebrates operators that select orbits that are less crowded and create fewer conjunctions concerns. The data sharing module gives credits to operators that share information about their location and maneuver to improve the process of coordination regarding right-of-way. The collision avoidance module gives credits to the operators that provide contact information for collision avoidance, make an effort to improve their knowledge of the location of their space objects, and coordinate proactively to review conjunction warnings. Since yet there is no right-of-way standards, the SSR does not directly include credits for this behavior, but is designed to be regularly updated when new change occurs in space policy. Therefore, the future versions of the SSR could include actions taken by the space operators to conform in the right-of-way norms, such as providing information about the intent to maneuver under the right-of-way condition in a transparent way.
Thank you very much.
Finally, I would like also to mention that finally, the rating also should give information on how sustainable the mission is and can help also operators to act in a more sustainable way, but also allows them on communicating on this. I hope that the more rating we perform, we can also provide a state of space sustainability with indicators that are others than the number of conjunctions, the objects, which we know have their limits based on the data that you have, the accuracy of the tracking, the ability of the spacecraft to perform a collision avoidance or not. Also that this information will be also very useful for policymakers when they come together to talk about international space traffic governance and have then an informed conversation on the right-of-way. So to conclude, this conversation on the right-of-way is happening and is inevitable in order to ensure a sustainable out of space.
Thank you very much, Emmanuel. And as we continue to hear, it's about communication, communication, communication. How do we overcome the barriers that prevent that effective communication? What do we need to be exchanging, and how do we get those messages across? Sometimes across cultural barriers, language barriers. These are all things that we're going to have to be considering. And even though we're talking about very technical issues, these are fundamental human issues. You know, how do we communicate with one another? So this is a very interesting trend that we're seeing. So along those same lines, Zach, let me turn to you, sir. Is this sustainable? Is the growth that we're seeing currently sustainable for the future? And are there any lessons that we can take from other domains that might help us to better plan or better coordinate amongst each other so that we don't, overuse our global commons?
Yeah, a great question. Is this sustainable, or is the growth sustainable? Well, it depends on how we define sustainability. We could probably get 200 different answers on sustainability right now in terms of risk. We want to incorporate safety into this, or just the question of like, are orbital regimes becoming economically unviable because of what really the issue here is congestion, right, of activities, right? A sidewalk or a road that has no other cars or people on it, that we don't have to worry about right-of-ways or giveaways so much. But as we become more and more congested, the costs that we impose on each other become more important. So what we're working at the University of Colorado in Boulder is developing the Space and Sustainability Initiative, and to build the business case for sustainability, and to show that by incorporating the costs, considering these costs, it's actually in the business, in the commercial sector's interest to act responsibly. And part of that we're looking at with Dan and Comstock and Secure World Foundation is developing norms of behavior, right, with respect to right-of-way, and to think about where we're likely to see norms of behavior develop on their own, and where we need to see institutions, which is to say the rules that we use, evolve in a way to respond to these new needs to act sustainably. Now, you know, I come at this from an economic perspective, and we need to consider that space is really a common resource. And I mean that in the economic definition, not the political definition of space commons, which is to say, is it excludable? Can we exclude people from accessing it? And the answer to that is in large part no. And the other aspect of that is it rivalrous, which is to say, does our use of space resources diminish the ability for others to use them in even small ways? And the answer is yes. So by those two aspects, space is a common resource, and therefore how we organize around that and handle externalities, the cost that we impose on others, well, we've got a number of different tools that we can use that. If we could privatize orbital regimes, for example, we could avoid a lot of costs, but I don't see that happening. Or you could impose an orbital use fee to internalize those external costs. I don't see that happening, right? So what we're left with is collective action, developing norms of behavior, and formal and in large part informal rules to take into account the costs that we impose on each other. Now there's a lot of common resources terrestrially that we can look to see how resources have been managed well or poorly in the past. One of the important lessons that I see is that if you act early, it's better than acting later. You can avoid a lot of costs by acting early. And what I've seen in this conference is that there's a lot of interest in developing norms of behavior, developing tools to avoid removal of orbital debris, or taking other actions that are in the benefit not just the individual, but of everyone. A second thing to consider is shirking, and this is something that David mentioned, right? Like, if for those organizations that behave well, right, develop maneuverability, procedures, it can create an incentive for others to behave badly, right? Because they can avoid those certain costs, and so that's another aspect of why building norms of behavior is so important. And so how's that going to happen if norms are really the expectations that we have for how others are going to behave, right? And so then, in some sense, they're very informal and they lack enforcement mechanisms. And so there needs to be kind of a social disapprobation. In economics, we'd say there's bounded rationality. We care what other people think of us. And so this is an opportunity for the United States and her allies and to take the lead on that. And things like the sustainability rating is a step in that direction.
No, that's absolutely true. And to echo our the late Mark Meany, who had really helped us with a lot of the thinking here, it would be much better for industry and for a lot of the operators to come together and start coming to an agreement on some of the norms and some of the ways that we should be acting well before the regulators start getting involved. Because let's face it, usually when the regulators get involved, it's overkill. So with that, I'd like to open it up for questions, and we've got lots of good ones coming in. So let me start with the first from Mark Mulholland. Risk management involves assessments of both likelihood and consequences. Except for human spaceflight, we rarely consider the consequences. How does the panel view including consequences in collision risk assessment? Dan, perhaps we can start with you on this.
Yeah, there have been looks at that. I can cite a group that CNES, NASA, I know T.S. Kelso was involved with that some, and some others have looked at. When you assess the likelihood of collision or probability, that's a piece of it, but in terms of sustainability, then you need to look at the consequence and how many fragments are produced above some certain size or mass. That's kind of the consideration on that. So those things are being looked at, but they're not commonly looked at in terms of products that are being generated today, conjunction data messages. I think we did introduce an optional field into this, the current revision of the conjunction data message to allow something like that.
David, would you have something to add to that?
Yeah, certainly we haven't come to the place yet where we're making priority decisions between maneuvers whereby we would want to consider consequence in order to prefer one maneuver over another. And so, yeah, so I think it's important that this discussion happens. I saw a paper that Darren McKnight was a co-author on recently that talked about using, just using mass as a driver on the consequence side, because larger the mass, the more potential debris products would be produced in a conjunction. But as of yet, for us, we don't consider the consequence because we haven't had to make the decision to not maneuver to avoid one conjunction because there's another one that has a greater consequence.
Thanks. Another question from my colleague Victoria. How do we develop common understandings amongst, how do we develop common understandings about right-of-way when there is so much distrust amongst actors right now?
So I'll jump on that one because you were looking at me. There's distrust between actors. That's a reality that we're going to accept, and that's a reality that exists in other domains. And we need to focus on this question of the safety information. We're not looking for your business model, your competitive information, your mission purpose, but what is the safety data that we need to extract so that we can all operate more safely in the domain? And when Dan makes his presentation, there's no agreement on threshold for maneuver. That's kind of an important measure. Like, how do I know when you're going to measure? If I know what your threshold is, I can have a better expectation. But what amount of information are you going to share? So this is the big question of information sharing, and it cuts across all of these domains. So we can say, let's develop a rule for who's going to give way in a certain scenario. If X happens, you'll do Y. Or we can develop a standard that says, in order to be a good actor in this domain, you need to share this information. Not everything, not all of the information you have. The information that is necessary to maintain the safety and the capacity of the domain. And this is important as well. Safety and capacity are not divorced partners. It's well known I came from aviation. And in 1969, the skies were full when you couldn't put another airplane up there. It was a delay crisis. And in about 1999, we did it again. The skies were full and we had a terrible delay crisis. And yet aviation continued to grow. And we continued to put more and more planes in the sky. How? Because we shared more information through automated means. And automation is very important. So the standards that we should be looking at is, what do we share? How do we share it? And what is the standard of that information sharing, so we're not having to put a human in the loop to reinterpret and to do the translation. So parties don't trust each other. How do we overcome that? There isn't going to be a bilateral agreement between two people that haven't agreed on anything in the whole history of time. Can you establish a system where the automation provides the trust, that we all agree that this system is able to say that data is true, that data is trackable, that data is immutable, and whether or not it's accurate is a different question. The fact that you put that information into the system and shared it and it cannot be changed, this is why I have a paper on using blockchain for information sharing, allows us as a community to track it back, and it creates a disincentive to provide bad information because it's tracked, and we can all check, and you can't change it. So you have to look to other systems to get away from that human value proposition, and to what extent can we agree on the information that needs to be shared, and what are the technological approaches. So like aviation, we can triple capacity and still maintain the same safety record. And in fact, safety rates are important. So if we maintain the same accident rate as we had in 1969, we'd crash an airplane every 3 days. That's kind of untenable. So you have to increase your safety record with the increase of traffic, because your raw numbers can't continue to go up even though your safety standard is the same. So putting all these things into automated processes helps overcome that trust issue, because it takes the human out of that decision-making process. It's not easy. I'm not, thinking we open a box and everybody's happy and it's great, but it's a path that we can start to go down to try and address these questions.
See, I was looking at you for a reason. Emmanuel, what do you think?
Thank you for asking. Actually, I was thinking also that maybe trust can come more, I would say, in how each other can verify themselves and their behaviors, and that comes in the way of capacity building. Maybe we would say that, for example, in SSA capabilities, the US were leading the way since a few years ago, but we can see also that now you have some commercial actors like Leo Labs, for example, in the US, but also in Europe, they are also developing capabilities, and there are also commercial actors that are entering the SSA market. And maybe this is a way that this trust will come as, I would say, space is getting more transparent, and there are more and more, the technologies are more and more accessible in order to verify who is doing what. So yeah, that may be one of the answer I could give to this question.
Thank you. David, there are a lot of questions coming in for you. Some of these might even be a little controversial, so please feel free to say that you're going to answer a different question. But one question that has come up, can you give us any numbers on how many autonomous maneuver decisions the Starlink Constellation has done to date?
I haven't looked at recently the numbers as of today, but we did submit a report to the to FCC that outlined the reports for the first half of basically the first half of the year. I think it was December through May, and we did over 2,000 CA maneuvers in that time frame. The average per satellite during that time frame is 1 to 2 per satellite, and so not a terribly high number for that number of spacecraft, but we're also using a lower threshold for maneuver at 1 to the -5, and yeah, we're going to err on the side of maneuvering in order to keep space safe.
Another question for all the panelists. Are there any minimum maneuverability standards that satellite operators are required to adhere to? Are there any in the works?
I'll start with that. This is pulling the thread, and a lot of the comments today have been pulling the thread on kind of the hidden thing that we really haven't pulled out in the open. And it ties to our research paper, which found that operators are using different criteria in GEO, LEO, everywhere. Well, why is that? It's because the operators are picking criteria that meet their needs, their customer set, their mission. It's not for space sustainability, for example. So the question about shouldn't we be looking at, risk as a function of, consequence and likelihood, that implies that the operators should be evaluating the mass and the sustainability impacts. Whereas, operators today, I think largely are focusing their criteria on their mission and protecting their asset. And if it got hit, you'd have to replace it. How long does that take? How much does that cost? So that's the hidden thing here. And it actually, I can generalize this to the types of standards that exist. There's prescriptive standards that says you must live with this number. And there are the safety case, where the commercial actor is allowed to explain why they're safe and show the analyses they've done to show that their methods make them safe. And so that's the question. The last comment here is, Ruth had very good points about giveaway instead of right-of-way. There's also rules of the road. I think the second part of that issue is, are they rules? Are they guidelines? Are they conventions? Or are they agreements between people? And one of the things in UN COPUOS, as I've been an observer there, I've come to appreciate with the Space Safety Coalition is a lot of times people say, well, we need more treaties. Well, no, we have treaties. They work in a very complementary way with the aspirational things that the commercial industry can do. And they're both valid, and we shouldn't say we should only do one or the other. So to me, yes, there's a lot of countries looking at right-of-way and rules of the road, but we have to wrestle with that question, because if they're rules, that's on the prescriptive side, and that can introduce its own difficulties. Thank you.
Anybody else?
Yeah, I'd like to build on what you said about consequences, because it's important and how you view consequence. Like the point I tried to make about right-of-way is you have policy-based and you have situational-based. So when you come to consequences, you can look at the consequences to your satellite, your business, your operation, but weighing the consequence to the sustainability of the domain is a much more difficult question. And if we look to the environmental world, we see that often those standards come far too late, and we are in a cleanup situation versus a sustainability situation. And the environmental standards globally have been extraordinarily difficult to tackle, and we are heading down that very same road. So when we talk about consequence as a community, we need to continue to talk about consequences for the domain when we talk about the specifics. I understand we all talk about long-term sustainability goals, but when we talk about these sub-issues, we need to introduce that into the issue as well. Right-of-way is not just about the consequence to your satellite, it needs to be about the consequence to the environment as well.
Zach, anything to add? Okay. There is a question here on the, of course it was going to come up. What is the plan for when the Kessler syndrome takes over? And do the panelists think this is an if or a when? Dan?
Oh, I get this one. Yeah, the Kessler syndrome is a real thing, you know, and we are started down the path. But the question is, when do we have secondary or tertiary fragments, so fragments that come from one collision that then went to another, that are massive enough to really get to a chain reaction standpoint? Those spatial density pictures I showed with the red and the green and all that, the red is one object in 100 by 100 by 100 kilometer box. That's red. So, like I said, we're not to a dire situation yet, but those things move, so they conjunct with other things, and it's a real thing. You know, we're not quite there yet, but one thing I want to point out with one of Zach's comments is, you know, a lot of people say, well, there should be an economic incentive for operators to do the right thing. But Zach also said, on an uncrowded road, it really doesn't matter much. And so the issue is that if you have an operator driving on an uncrowded road, they can be all sorts of sloppy, and they're not going to cause anything. And the problem with the financial incentive part is, I think by the time there really is a financial incentive for operators to act responsibly, it will be too late, because we'll already have been on the crowded part.
Yeah, I would agree with that. So the Kessler syndrome is the 2 degrees of temperature rise for the climate. And so we can debate the horribleness of the end result, but the fact of the matter is a lot of bad things happen along the way. So it doesn't really matter when or if we have a Kessler syndrome. We have a problem today that is a result of congestion and debris generation in space that we need to address. So my answer to that question is whether it's when or if, it doesn't matter, because we have the consequences of the things that would lead to it, and we need to deal with them today. Their economic costs, the ability for us to continue to provide these services to Earth are important. So it's an interesting bar talk. Kessler syndrome makes great movies, but we need to address the problems of congestion and threat, whether or not that is the end result.
Absolutely, and once again, that stresses the importance of sustainability. Zach?
Yeah, this is the problem of decision-making under uncertainty, of like when this will happen. But it's, as I said, taking action now is easier than it would be later. As the kernel of the presentation of, the United States has, in terms of active objects, nearly 50%, 5 major nation-state actors, but that number is increasing, right? And so if we set these norms now, that other nations and commercial actors in other nations adhere to, then we're more likely to avoid these really bad outcomes.
Thank you so much. And I'm just going to turn real quick to our virtual colleagues and say, do you have any closing words before we finish the session?
Well, I definitely really appreciate the opportunity to be able to participate here, Daniel. And yeah, I think in the big picture, like 2 things. One, we need a sense of urgency to address things that we can to avoid Kessler syndrome, right? There are things that we can do to make space safer, and I think we all need a sense of urgency to do what we can to avoid that. And the second thing is, in the area of trust, let's build trust. Let's all work on building trust. Let's trust others, and let's be transparent and open, and let's start to prioritize transparency rather than protecting our proprietary concerns or protecting our business interests. Space safety is too important for us to not do that, and so we've got to build trust there.
Thanks, David. That's really important message for us to take away. Emmanuel?
Yeah, thank you very much. So I think I would like also to build on what Ruth and David said, that indeed there is this sense of urgency, and I really like also this parallel with the current climate change crisis. I think Kessler syndrome is something maybe we will inevitably also go to, and that's why we need to act now and not wait. That say we don't need to have the Greta Thunberg of space to tell us this. Also, but I'm also very confident that I would say what's happening in the last year, the behavior of commercial actors, I would say the opening of the conversation, the fact that also UN Corpus managed in 2019 to come out with the long-term sustainability guidelines, and also the, I would say, incredible technology developments that are happening and that are really also changing the landscape with new let's say you're going to have intelligent satellites, you have much more capacity to also see what's going out there. This is possible, and also that we should keep in mind that today we face the issue in LEO also with large constellation, but then tomorrow you have a lot of people that are going to go on the moon and then on Mars, and the way we're going to solve this there near Earth, so just in LEO, will be also the building blocks for, I would say, human exploration and then the really long-term use of outer space. So we need to make smart decisions now.
Fantastic. Thank you so much. Ladies and gentlemen, please join me in thanking all of our panelists. We look forward to seeing you all throughout the rest of the conference. Thank you very much.